Hi everyone, this video will teach you how to multiply polynomials. This is going to build off the lesson that you learned previously with how to classify, add, and subtract. Now we're moving to the next operation, which you'll learn how to multiply. Division is another operation you can do with polynomials. That is something you're going to learn about in Algebra 2 because there are a lot more components to that than there are to the other three major operations. So, multiplying is going to build off a skill that we've definitely gone over a billion times this year, how to distribute. So the key is, instead of just distributing maybe one term to a bunch of things, now we're going to have to distribute two, maybe three terms to a bunch of different things. So this case here, it's just a matter of being orderly with your work and making sure that you accurately apply everything. Now, the main difference with multiplication versus the other operations, when you look at them, is making sure that the expressions are directly next to each other. You will not see a sign, a plus or a minus, in between two polynomials if they need to be multiplied to each other. So you need to make sure that if you see a plus or minus, that's adding and subtracting. That's combining like terms. That's its own separate deal. Multiplication, you are doing a whole bunch of distribution. So that's one of the major differences. The other major difference is how do you put terms with variables together. So let's talk about here and review with A. We're going to distribute that 5x squared. It's one singular term getting distributed to everything in the parentheses after it. So we multiply those coefficients together. 5 and 2 multiply to 10. When we multiply x squared and x cubed, remember, key rule about exponent math, when we multiply things with the same base, in this case they both have x's, and you have your different exponents, you add them together. So when I have x squared and x to the third, that makes x to the fifth. Then I'm going to take the 5x squared times negative 10x. 5 times negative 10 is negative 50. X squared times x, keep in mind that's like an x to the first. We add the exponents again, and that makes x cubed. So I get a final answer of 10x to the fifth minus 50x cubed. So a primary difference here with multiplication, especially when it comes to your exponents, is that they will change when you multiply different terms here, especially with variables. So you do need to account for that, and you need to make sure that you apply the exponent rules correctly. So when we multiply the same base, we add our exponents, and you will see changes in those. Unlike addition and subtraction, where those always stay the same. Now, we've distributed terms like that before. Now what we're going to do is review how to distribute if I have multiple terms in an expression that need to be distributed. So here in B, I have x minus 4 times x plus 2. Everything from the first polynomial has to apply to everything in the second polynomial when it comes to multiplication. So here's what that means. The x from the first polynomial is going to get distributed to the x and the 2 of the second polynomial. Then I'm going to take the negative 4 and apply it to the x and the positive 2 of the second polynomial. So I'm doing what I call double distribution because I'm doing two waves of it. I'm distributing the x from the first polynomial and the negative 4 from the second polynomial. I draw in a little distribution here again just so I can kind of see, hey, I need to do 4 different waves of math, and I'm going to end up with 4 terms here. So if that helps you, great. If you don't need that, that's fine too. So x times x, I'm going to put together. That makes x squared. Again, I'm multiplying, so x to the first and x to the first would make x to the second when I multiply. X times 2 is 2x. Now I'm going to do negative 4 times x. Make sure you carry that negative, so it's negative 4x. Negative 4 times 2, that makes negative 8. Once you do your distribution, just like anything else, if you have any like terms, combine them. So clearly we have 2 of the same types of x's, so we'll just combine like terms. 2x and negative 4x make negative 2x. So this would simplify to x squared minus 2x minus 8. And I realized in C here that I've got the exact same problem because clearly I copied and pasted and forgot to change things. So you know what? We're going to do this on the fly here and fix it. So let's take a look here. And I'm going to go ahead and change out the... Let's change this out here. So we'll do this on the fly. We'll do 2x plus 7. And let's make the other one x minus 5. just so we have some different numbers, because there's no point in having the same problem twice. So as we go ahead and do that, I'm going to go ahead and, once again, the 2x has to apply, and so there's a 7 from that first binomial to everything in the second binomial. So 2x times x will make 2x squared. 2x times negative 5 will make negative 10x. 7 times x will make 7x. And 7 times negative 5 will make negative 35. I have, again, those two like terms in the middle to put together. So that'll give me an answer of 2x squared minus 3x minus 35. Now, if you look in D, you can clearly see that we now have a trinomial out in front. No big deal. It's the same thing. You take everything from the first polynomial and make sure it applies to the second polynomial. So I'm going to take the b squared and distribute it. So I'll do that here first, just so I can be a little bit more organized. B squared times 3b will give me 3b cubed. B squared times negative 4 b squared. Now I'll take the 6b and distribute it. 6b times 3b is 18b squared. 6b times negative 4 is negative 24b. And now I'm going to take the negative 7 and distribute it. Negative 7 times 3b is negative 21b. Negative 7 times negative 4 is positive 28. Again, the more terms you have, the more chance, the higher the chance, I should say, of you accidentally screwing up a sign. Make sure you take your time in doing these. It's really easy to accidentally make a negative a positive or vice versa, and it'll throw your whole final answer off. Now, we look here. I've got b squared terms that can go together, and I have, I guess I'll do that here in a different color, b terms that can go together. So, two sets of like terms, just combine them together. So again, the 3b cubed comes down. Put your b squared terms together, that becomes positive 14b squared. Put your b terms together, that becomes negative 45b. And the positive 28. And you get yourself your final answer. 3b cubed plus 14b squared minus 45b plus 28. The most you'll really ever have to realistically do is something the size of D or E, where you've got a trinomial times a binomial. Again, theoretically, you can have an infinite amount of terms to multiply together. And notice, there's really no restrictions on what we multiply. Whatever I want to multiply, I can put together somehow, some way. So with E, here I just have it in a reverse order, where I have the binomial first, and that's okay too. So I'm going to just go ahead and take whatever's from the first term, distribute it to the second. So 4x times 2x squared gets me 8x cubed. 4x times 5x gets me 20x squared. 4x times negative 1 gets me negative 4x. Now I'm going to take the negative 3. Negative 3 times 2x is negative 6x squared. Negative 3 times 5x is negative 15x. And negative 3 times negative 1 is a positive 3. So, once again, I'm going to combine my like terms. Notice they're not right next to each other this time, which, again, is totally fine. Doesn't matter what order they're in, as long as you realize they have to go together. 8x cubed will stay out front. You put your x squareds together, you'll get, again, positive 14x squared. Put your x's together, you get negative 19x. And then the plus 3 to tack on at the end. You'll notice, again, with all of these answers, I'm making sure they're being written in standard form. Highest degree, highest exponent, all the way down to the lowest or no exponent. Now we get to F. Now, what's going to be really, really tempting, and this is something we'll emphasize a little bit more later here in the year. What's going to be really tempting to do is to want to distribute that squared. That is a big, big no-no. And the reason being is because there's that plus sign in the middle of my terms. If you're trying to square an expression that has a plus or a minus sign in it, doesn't matter if there's even one of those signs, you cannot distribute the exponent. That is a big no-no. So you know what? I'm even going to write that in fire red here. Don't distribute the exponent. This is something even in Algebra 2 I go over every time it comes up, because it's something that's very, very tempting to do. And it's an easy mistake that a lot of people make. But do not distribute the exponent. You cannot do that in this case. So that we have to come up with another solution. Well, how am I going to square 3x plus 4? Think about what it means to square something. What it means to square something is to multiply it by itself. Like if I'm doing 8 squared, that's the same thing as 8 times 8. If I'm doing 3x plus 4 squared, it's the same thing as doing 3x plus 4 times 3x plus 4. All I'm going to do in this problem, if I see that I need to square an expression, is write it twice and then distribute it together. So it's exactly the same type of problem as B or C. It's just that we need to write it out. Okay, so I'm going to write it out twice and then distribute it together. So now I'm going to go ahead and just carry through the normal process. 3x times 3x, 9x squared. 3x times 4 is 12x. 4 times 3x is another 12x. And 4 times 4 is 16. Got a couple like terms, so that'll give me a final answer of 9x squared plus 24x plus 16. So that's the general gist on how you multiply these together. So it doesn't matter how many terms you have. Whatever's in the first expression, you make sure all of those terms get distributed to every term in the second expression. And that'll give you a nice, accurate set of answers. So we can apply this a little bit further here where we can do more operations instead of just worrying about multiplication. We can do addition and subtraction, all that stuff at the same time. And we're also going to apply it a little bit to the concept of finding area. So if you take a look further down, if you have an expression that has addition, subtraction, and multiplication, order of ops still applies. So keep in mind, your order of operations, you would multiply things together before you would try to add and subtract them. So if you look at problem set 2 here with examples A and B, it looks really confusing because you have so many different terms. But again, I see in both sets here things that need to be multiplied together. Then in A, I see a plus sign. B, I see a minus sign. We're going to worry about that stuff later. We're going to go ahead and take care of multiplication first before we worry about addition and subtraction. So in 2A, let's go ahead here and take a look at what needs to be multiplied first. So I see one way of a distribution, p times 2p minus 3. Once your parentheses end, you stop distributing. So I'm not going to take the p and distribute it to everything further down the line. That plus sign kind of cuts everything off. But once I do that, so let's do that here real quick. P times 2p is 2p squared. P times negative 3 is negative 3p. Now I'm going to go ahead and distribute the second wave. So I'm going to pull down that plus sign. So the other thing we're going to do here is this. Since this is two separate waves here, I'm going to go ahead and actually put these in parentheses so I keep them together. This, you'll see, will be important for example B, mainly that minus sign. We'll talk about that, though, in a minute. Okay, but I did the first group of multiplication, got my polynomial. Now I'm going to do the second wave of multiplication. So p times p is p squared. P times 3 is 3p. Negative 3 times p is negative 3p. Negative 3 times 3 is negative 9. So I'm going to first see if I have any like terms I can combine in these little sets. So I'm going to go ahead and look at the second polynomial. 3p and negative 3p would cancel out. So I'm left with just p squared minus 9. Now that I've simplified, I multiplied those two different clumps together, I simplified. Now I can go ahead and take care of this plus sign in the middle. So since it's just addition, I'm just going to add these together. So I've got p squared terms, I've got a p term, and a constant. So all I'm going to do here is combine the p squared terms. 2p squared plus p squared is 3p squared. Bring down the negative 3p, bring down the negative 9, and I've got myself a simplified answer in standard form. So I'm multiplying each section together first, simplifying each down as far as I can. Then I'm worried about adding the results. So again, PEMDAS, take care of the multiplication, simplify as far as you can, then do the addition. In B, we're going to do the same thing. We're going to multiply each set together, and then we're going to take care of that subtraction sign in the middle. So in B, I'm going to distribute the negative 3c squared. So negative 3c squared times c is negative 3c cubed. Negative 3c squared times 11 is negative 33c squared. So that's clump number 1. Chunk number 2, 4c times 3c is 12c squared. 4c times negative 2 is negative 8c. Negative 5 times 3c is negative 15c. Negative 5 times negative 2 is 10. I'm going to go ahead. So the first chunk here has no like terms, so I'm going to leave that alone. The second chunk has a couple like terms. It has those c terms in the middle. So I'm going to condense that and make that negative 23c. Now, what's really important here, and why I put parentheses around these, for addition problems, it doesn't really matter because you're just combining like terms. But as I talked about in the last lesson, subtraction means you have to make sure that subtraction affects everything that comes after it. So I'm going to put that minus sign. I'm going to apply it to all the new terms that I have after it. So again, the first expression doesn't change. The second expression does. So the 12c squared becomes negative. Negative 23c becomes positive. Positive 10 becomes negative. Now I can go ahead and combine my like terms. I only have one set of like terms. It's those c squared terms in the middle. So I get a final simplified answer of negative 3c cubed minus 45c squared plus 23c minus 10. And that is your final answer in standard form. So again, that's just taking a look at combining multiple operations together. Again, you won't have to worry about doing a bazillion problems like that, but it's a way that we can tie all three operations I've taught you together in one set of problems here. Final problem here is to look at a couple of real basics with perimeter and area of a rectangle. Now, we talked about perimeter in the last lesson, and as you know, perimeter is simply adding all the sides of a shape together. To find the area, as you'll learn in geometry down the line, there's lots of different ways to find area. But when it comes to finding area of a rectangle, area is simply length times width. Or as you might remember as a formula from middle school, A equals LW. So, this is telling us to find the perimeter and area of a rectangle with a length of x plus 6 and a width of x minus 4. Now, anytime you have a problem with a shape, not saying you have to do this, but sometimes it's good to just sketch it out. So keep in mind it's a rectangle. It doesn't really matter what you call length and width. Typically, I think of length as across, width in this case is up and down. So I'm going to go ahead and label it. Now, let's talk about the perimeter piece first. Perimeter involves me having to go the whole way around the rectangle, not just part of it. So remember, a key property about a rectangle, whatever one side is, the side opposite it has to be the exact same measurement. So if the top of my rectangle is x plus 6, so is my bottom. If the left side is x minus 4, so is the right. So if I'm going to find the perimeter, I need to make sure to have 2 of each of those measurements. So I'm going to have x plus 6 plus x plus 4. I'm sorry, x minus 4 plus x plus 6 plus x minus 4. We're going to add all those together and get a perimeter of 4x. Then we combine all of our numbers here, so that comes out to positive 4. So my perimeter is 4x plus 4. To find the area, we've now established area as length times width. So I'm going to take the x plus 6 times x minus 4. Okay. So we're multiplying these now rather than adding them, and you only need one of each because that's how you find area. So we're going to distribute the x and distribute the 6. So my area, again, x times x is x squared. X times negative 4 is negative 4x. 6 times x is 6x, and 6 times negative 4 is negative 24. If you have like terms, like you typically will, you combine your like terms together. So you get an area of x squared. Combine those x's, you get positive 2x minus 24. And that'll be your final answer to find both of those. So they're two vastly different measurements, that require two different sets of calculations. Again, nothing too complex, but you do need to make sure that you have everything that you need. And again, the visual aid of drawing it out can be helpful for probably some of you. Some of you can probably do most of this in your head anyway. That's just really, again, personal preference there as to how you want to solve that. But in short, that is how you multiply polynomials together. Nice little review there. Also involves a lot of adding and subtracting concepts. But that basically sums up the basics of what you need to know about polynomials and their basic operations. Your assignment that ties with this lesson. So again, I know I said in the last video that not everything's going to be IXL. Admittedly, some of these earlier ones, it's going to seem a little IXL heavy, but we do spread them out once we get beyond this week. So once again, there's an IXL that will go with this, sticking within our level K as we've been all year. Oops, try that again. The topic that will go with that is Z10. So that's just straight up multiplying different things together. And again, it's going to be like the adding and subtracting topic. You want to make sure that you're very careful in entering your details. If you're trying to do it too quick, or you're trying to do the handwriting part and it's real sloppy and it messes up, it is not going to be forgiving. So make sure you, again, do the problems on a separate sheet of paper or on the screen. Really show your work out and make sure that you do things right the first time through. Again, if you have any questions about this lesson, about the assignment, etc., please make sure that you get a hold of me so we can iron out any problems that you may have. Again, pay attention to due dates. This assignment and your IXL from the last lesson, those are both due by 9 a.m. on Tuesday, the 14th of April. So please make sure those are completed so you get your points. Again, grades will be kind of at a premium, but the grades that you do get will be pretty easy to attain as long as you're keeping up with the work. So again, if you have any questions, please get a hold of me. Otherwise, thanks for watching, and we'll talk to you next week.